There is a very special genre of internet video where someone stands next to a body of water, points a camera at something, zooms in aggressively, and announces, "Well, looks flat to me." And apparently that's it. Physics is cancelled. Centuries of astronomy in shambles. Pack it up, everyone. Dave bought a zoom lens. Let's explore this. Hello there, welcome to Star Stuff, where I apparently provide a safe space for flat earthers and others to freely raid my comment section and start some much needed conversations. Today we're talking about telescopes, optics, and why
I can see too far
is not evidence of a flat earth, but is excellent evidence that optics is wildly misunderstood. And yes, of course, no NASA required, no rockets involved, just light, geometry, and a bit of common sense that didn't get lost at sea.
Well, show us on a ball Earth, Dave. Yep. You have to have a physical horizon, right? If my fingernail is a boat, as it goes away, it disappears below a physical horizon, and zooming in will not bring it back. However, we can see too far. They say the ball is 24,901 miles around, but we can see things that are way, way, way farther. And with infrared now, we're seeing things 500 to 1,000 miles away. The amount of curvature.
Let's start with the basics because conspiracies love skipping that part. A telescope does three things. It collects more light, it improves resolution, and it magnifies detail. That's it. No bending reality. No flattening planets. No secret setting marked "expose the truth." Zooming in is the optical equivalent of putting on glasses. If glasses let you see through walls, optometrists would be a national security risk. A telescope can only magnify the light that is already reaching your eyes. If light is blocked by Earth's curvature, the telescope has nothing to work with. No light in, no conspiracy out. This claim shows up everywhere. It vanished in the distance, and then I zoomed in and it came back.
Can you see a ship which is going?
Let's talk about the ship that goes over the curvature of the Earth. I love it. So science has said that when I see a ship go out of my field of view, it's going over the curvature of the Earth, correct?
Yes.
But then I bring my P900 up, and guess what? I can zoom it back in. So is it going over the curvature of the Earth or not?
Here's what actually happened. Never vanished. Your camera hit its resolution limit. Zoom simply revealed detail that was already there. The zoom feature doesn't pull objects up from behind the horizon, or bend light upward, or negotiate with geometry. If zooming in could retrieve hidden objects, telescopes would be used for time travel and lost socks. This is a clarity issue, not a curvature one. The "I can see too far" argument. This argument sounds persuasive until you look at what it quietly ignores. Number one, height exists. If you're standing higher, you can see further. If the object is higher, you can see it from far away. This works beautifully on a curved Earth. Flat Earth distance calculators love pretending that people are standing at sea level, observing objects also at sea level, on a perfectly calm, perfectly unrealistic Earth. Reality did not sign up for that model. Refraction. Yes, it's real. No, it's not magic. Refraction bends light slightly downward as it passes through air. The important word being slightly. Refraction can lift distant objects a bit, stretch images vertically, or cause mirages or distortions. Refraction cannot consistently erase kilometers of curvature, work the same way every single day, be selectively strong only when someone needs it to be. If refraction were powerful enough to flatten Earth visually, surveying wouldn't work, GPS wouldn't work, aviation wouldn't work, and astronomy wouldn't exist. But somehow, Flat Earth YouTube relies on it. Distance is not proof of shape. Seeing something far away doesn't mean Earth is flat, or geometry is fake, or space agencies are trembling. It means light reached your eyes from a point still above your line of sight. So distance is not evidence. Otherwise, binoculars would come with a warning label.
And one of the main reasons why we believe that the Earth is a fixed stationary plane is because things aren't disappearing as quickly as they should be. We can see cities and mountains and islands 40, 60, 100 miles. The world photography distance record is 273 miles, right? And we can see the tips of the Pyrenees from the south of France, and you shouldn't be able to
can't see the base of them.
Well, of course not.
Because the Earth is round.
Here's where telescopes actually get awkward for flat Earth. When people use telescopes properly, they consistently observe ships disappearing bottom first, lower parts of buildings vanishing before upper parts, objects reappearing only when the observer's height increases. This pattern was already noted centuries ago by observers like Galileo, who somehow managed without CGI, Wi-Fi, and monetized outrage. Even the famous Bedford level observations show predictable obstruction, height-dependent visibility, and results that match a curved Earth every single time. So telescopes don't hide curvature, they make it painfully obvious. Let's talk about space denial for a moment. With a basic backyard telescope, you can observe Jupiter's moons changing position night after night, Saturn's rings tilting over time, Venus going through phases, crescent to full. These observations cannot happen in flat or geocentric models, and they were recorded years before modern space agencies, and they are repeatable by literally anyone. No rockets, no green screens, just gravity doing its thing, ruining perfectly good conspiracies. The "I trust my eyes" claim. Will your eyes also tell you that parallel train tracks meet in the distance? Human perception is excellent at confidence and terrible at scale. Science exists because our intuition is often wrong and very sure about it. Telescopes don't prove Earth is flat. They prove why measurement beats vibes all the time. So when someone says, "I can see too far, so the Earth is flat," what they're really saying is, "I misunderstand optics and ignore geometry, and I feel really extremely confident about that." So telescopes don't flatten Earth, they flatten bad arguments. And the universe remains inconveniently, stubbornly round, measurable, and completely unimpressed by zoom cameras. Thank you so much for watching. If you enjoyed this video, please like and subscribe so you can see more of these videos. Cool beans.